Alright, let's get started. Let's talk about factoring, everybody's favorite subject. Okay, first thing we're going to talk about is going to be the greatest common factor. So looking at this, you want to find out what they all have in common via dividing, and always factor out the GCF first in every single problem that you do. So 6, 15, 9, and 3. Biggest number that divides into all of those will be a 3. There we go. And then this has x to the third, x to the fourth, x to the fifth, x to the second. So how many x's did they all have in common? Well, they all have, at most, they all have 2. All right, so x squared. And then looking at the y to the first, y to the second, y to the sixth, y to the first. So the most we can take out is a y to the first. Then we divide. 6 divided by 3 is 2. X cubed, take out x squared is x. Y take out y, it's gone. 15 divided by 3 is 5. X to the fourth, take out x squared is x squared. Y to the second, take out y is y. Bring down the negative. 9 divided by 3 is 3. X to the fifth, take out a x squared is x cubed. Y to the sixth, take out a y. Y to the fifth, bring down your plus. Now look at this. Some people freak out of this. 3 divided by 3 is 1. The x squared's gone, the y is gone. So it's just a 1 that goes there. Some people put a 0 there. That's a very common mistake. So make sure you're realizing this is dividing. So 3x squared y divided by 3x squared y is 1. Over here, 6 and 5, they don't have anything in common. And x cubed and y, the 6 has nothing in common. So this is unfactorable. Okay, so sometimes you will have an unfactorable. Not very often. Over here, there's a y that they both have in common. So we'll pull that out of here. Now, y divided by y is 1. There's where people make their mistake. You should always get the same thing when you multiply back in. 15y to the 8th, take out a y. 15y to the 7th. Now remember, if I'm going too fast, your best bet is to watch it the first time and write everything down, and then go through it, a second time, and then just watch it, okay? Alright, so reverse FOIL, distributive property, guess and check, whatever you want to call it. When you have 3 terms like this and you've pulled out the GCF, the way that you factor the rest is going to find out what 2 terms multiply to give you the number in front. So let me do this here. This ax squared, you want to know what 2 terms multiply to give you that. And then over here, for the c, you want to know what 2 terms multiply to give you that, and that goes at the end of the parentheses. Today's going to be easy, though, because our a is going to be 1. Makes the problems a lot easier. So let me show you what I mean by that. And by the way, if you have an unfactorable, you can always check to see if b squared minus 4ac, if it's a perfect square or not. And a, b, and c are just the numbers in front of each of these, just like you could see up here, a, b, c. If b squared minus 4ac is not a perfect square, then you can't factor it. Okay, so that will happen sometimes. So looking at this, our a value is 1, our b value is 8, and our c value is 16. What you want to ask yourself first, what numbers multiply to give you 1? And it's 1 and 1, so you don't have a lot of choices here. So you're going to have your 1x and your 1x. Then you want to ask yourself, what numbers multiply to give you 16? We've got 1 and 16, we've got 2 and 8, we've got 4 and 4. Okay? Now, I want my middle terms to add to 8, and that's your goal. And these problems are easier, so you can kind of look over here and see which ones kind of add to 8. So I'm going to say it's probably 4 and 4. So here's how you check it. And like I said, these problems are easier, but if you practice them the way I'm teaching them to you, the more difficult ones will be easier later. So this is 4x when you multiply it. Looks like a little face, little nose and a mouth. And this is 4x when you multiply it. Does that add up to be 8x? Yes, if they're both positive. And you can always double check it. Is 1x times 1x x squared? Yes. Is 4 times 4 16? Yes. And we already checked our middle terms, so you are done. Whenever there's a 1 in the front, these ones are super easy. You basically ask yourself what multiplies to give me 16 but adds to give me 8. Okay? We are focusing on some easier ones today. So here, the biggest mistake people make is they don't pull out GCF. So let's pull this 3 out of here first. And we have x squared plus 10x plus 21. So again, this is the easier type. This is the easier type problem. What multiplies to give you 1? Well, just 1 and 1. And you don't have to write the 1 in front of the x if you don't want to. And then things that multiply to give you 21. So we've got 1 and 21, we got 3 and 7. We want our middle to add to 10. So probably we're going to use positive 3 and positive 7. And you can check it. Is 1x times 1x x squared? Yes. Is 3 times 7 21? Yes. This is 3x when I multiply, that's 7x, and it does add up to give you 10x. So you have fully factored the problem there. Okay? Like I said, we're doing easier ones. When this number in the front isn't 1 anymore, much more difficult. Okay, so over here again we got 1, because that's what we do in today. And we got 16. So 1 and 16, 2 and 8, 4 and 4. Which one of these will give you a 10? The 2 and the 8, right? So we've got our 1x, 1x, and we've got our 2 and our 8. Now when we multiply these in the middle, we want them to add to be negative 10x. So we would want both of these to be negative then, just like that. And then always double check. 1x times 1x is 1x squared. Is negative 2 times negative 8 negative 16 though? It is not. And if I put 4 and 4 here, it's not going to add to give me 10, and 1 and 16 won't add to give me 10. So this actually does not work. This is unfactorable. Told you, it happens sometimes. You have to double check your work. Unfactorable. Let's look at 7. This one's weird because it has an x to the 4th, but who cares? When it was x squared, you did x and x. So when it's x to the 4th, because it's 1 and 1 again, nice and easy today, you're going to have an x squared and an x squared. That's the only difference. So instead of x and an x, you have x squared and x squared. And for 40, we've got 1 and 40, 2 and 20, 4 and 10, 5 and 8. Which one of these do you think is going to give you a 3? 5 and 8, right? So if we have 5 and 8, and we multiply the middles, I want it to be a positive 3x squared. So if it's a positive 3x squared, this would have to be negative, and this one would have to be positive. So this one's positive, this one's negative. And that's it. Double check it. Double check it to make sure it's the right. X squared times x squared is x to the 4th. We know our middles work out. Is negative 5 times 8 negative 40? Yes. So we are good. All right, let's keep on going. Multivariable. So always pull out that GCF first. So looking at this, I can see that they all have a 2. So x squared plus xy minus 20y squared. Now, this has an x squared in the front, so we're going to have a 1x and a 1x. And at the end, we have a 20y squared. Big whoopity whoop. Instead of just working on the 20, we're going to have a y and a y with it. So we automatically know there'll be a y here and a y here. So we've got 1 and 20, 2 and 10, 4 and 5. Which one of those is going to give you a 1? Probably the 4 and 5. And then when we multiply this, 4xy, this is 5xy, and we want a positive 1. So this would have to be negative, and this one would have to be positive. Double check it. Is negative 4y times positive 5y negative 20y squared? It is. So you are good. Over here, don't freak out about x to the 4th. Again, no big deal. So we've got 1x squared and a 1x squared. Then we got 90. That's a big one, right? 1 and 90. We've got 2 and 45. We got 3 and 30. I'm looking for this to add to be a 1, so we're still a little bit away. 5 and 18. 6 times 15, and then last but not least, 9 times 10. And there's where we can get a nice little 1 out of that. So when we multiply this, it'll be 9x squared, and this right here would be 10x squared. Okay, alright. So when I do this, if I want a positive 1, we want this to be negative. So this is negative and this is positive. Now I'm not going to box this problem because we're going to come back to it. Alright, we're going to come back to this problem because it's actually not finished. Alright, it's not finished. Let's look at these next couple of problems. We'll come back to it. So for difference of squares, technically it has to have a minus in the middle, and both things have to be perfect squares, aka can you square root them and be pretty. And don't forget, always take that GCF out first. So there is a minus in the middle with these two terms. The square root of 81x squared would be 9x. The square root of 100 would be 10. So plus 10 minus 10. Done. Over here, this has a plus in the middle. Can't do it. Unfactorable. Let's pause for a minute. Do you see how we did number 10? Hold up. Let's go back to this one. So, if we go back to this one here, let me scooch this back. Let's look at this right here. Do you see it? We can factor x squared minus 9. That'd be x plus 3, x minus 3, because we can square root both of those. Now this has a plus in the middle, so you're just going to bring it down, just like that. Boom. So see how that one went further? So some of your problems will go further. I know that that's not pure happiness, but it will happen. So just because there's a fraction here, who cares? Square root of x squared is x, square root of 16 is 4, minus, or plus, doesn't matter which one you start with. Square root of 9 is 3, square root of y squared is y, square root of 169 is 13. So if this one's a minus, then this one will be a plus. Look at that. Done. Scary, but done. 13's amazing. So we have an x to the 8th. So we're just going to use an x to the 4th then. No big deal. Don't freak out, because remember, it's got to be the same thing in both spots. X to the 4th times x to the 4th multiplies to x to the 8th. And then we've got our plus and minus 1. Now here's the deal. You can't go any further with x to the 4th plus 1 because of the plus sign in it, but you can go further with the one with the minus, because you can say this is x squared minus 1. Actually, let's do x squared plus 1, x squared minus 1. And then you can go further here. So if we have x to the 4th plus 1, x squared plus 1, and then we can go further here. X plus 1, x minus 1. This one's crazy and amazing. Alright, just keeps going and going. And then that's as far as you can go, because we can't go any further because we can't take the square root of x. This one here, biggest mistake people make, they'll say it's unfactorable, but it's actually factorable. You have to pull that 2 out of there first, and a lot of people forget to take out the GCF. For some reason, people completely forget about it. Now that it's out of there, square root of 4x squared is 2x. And the square root of 25 is 5. Plus, minus, minus, plus, doesn't matter. And it doesn't go any further than that. Last but not least, we got this guy here, and there's some x to the 4th, y to the 4th stuff. Don't let it mess with you, so we'll just have an x squared here. And then we have 8y to the 4th. Well, there's a couple things that can get you 8. 1 and 8, 2 and 4. And we want to get a 6, so it's probably the 2 and the 4, but it has a y to the 4th with it, so we're going to have to use a 2y squared. Oops. We said it's going to be 2 and 4. So we'll put a 4y squared here. Check your middles. 2x squared y squared, 4x squared y squared. I want a negative 6. That means both of these will have to be negative. Now, before you think you're finished, you're not, because look at this one right here. It goes further. So we're going to bring this x squared minus 2y squared down, and this one does not go further because you can't take the square root of 2. It is not pretty. I mean, you can. It's just disgusting. But you can take the square root of this stuff. This would be x plus 2y, x minus 2y when we take the square root of x squared and 4y squared. Now you're done with that problem. All right? Last but not least, zero product property. It's everything we already know, except we're going to take each chunk and set it equal to 0. Well, this entire thing has to be set equal to 0 first. So I'm going to add my 64 over. What multiplies to give you 64 but adds to give you 20? And I have found that as 4 and 16. Then you take each parenthesis, you set it equal to 0, and you solve it. So this one's negative 4, this one's negative 16, and you're done. Over here, take out the GCF of 5x. We have x squared minus x minus 6 equals 0. What multiplies to give you negative 6, but adds to give you negative 1? And that would be negative 3 and positive 2. So then you take each piece, set it equal to 0, and solve. Remember, if I'm going too fast, pause me. Who cares? It's all about you. Solve this and we get 0, 3, negative 2. There's our 3 answers to that problem. And there you have it. A little bit of factoring for you. I highly recommend watching this video multiple times because factoring is hard for a lot of people. So that is my recommendation to you. Until next time, goodbye.